certain kinds of solutes are electrolytes. These are solutes. Electrolytes are solutes that yield electrically conducting solutions. In order for a solution to be electrically conducting, it has to contain charged particles, like ions, and those charged particles also have to be mobile. They have to move around. So salt, for example, is not good at conducting electricity. It does have charged particles, positive and negative ions, but they can't move. They're stuck in a crystal. Pure water has mobile particles. Water molecules can move freely in liquid water, but they're not charged. And so that doesn't conduct electricity. So you need both charged particles that can move. What are some things that are electrolytes? Well, one is ionic compounds, in other words, salts. These things dissociate in water to release individual ions. Here's an example, very common one. Sodium chloride is an ionic compound. Dissociation means the crystal just falls apart, like we saw in that animated example, to give sodium ions and chloride ions, mobile charged particles. Acids are also electrolytes. They don't dissociate like ionic compounds because they're not ions, they're molecules. But they have ionization reactions that they do when they're in water, and that produces a hydronium ion and an anion. Here's an example. Hydrochloric acid is a fairly famous acid. If you put it in water, it reacts with the water and it produces hydronium ion. So the H from the hydrogen chloride goes to the water and makes H3O plus, because it now has an extra proton. And it leaves the electrons in the bond behind, and it makes a chloride ion. Now this is often modeled with just a simpler version of this, where the HCl just breaks apart into H plus and Cl minus and ignores the fact that the H plus is then going to react with water. So either way you write it is acceptable. The top way is actually what happens, and this is a model that many chemists use just as a simplification. So what things are acids? Here are the types of compounds that make acids. One is molecules that contain hydrogen atoms, like, for example, HCl that we saw will dissociate and give an H plus and a Cl minus. This is an example of something that's called monoprotic because it gives one hydrogen atom per molecule. There are some that will release two, like H2SO4, sulfuric acid, will release two H pluses and an SO4 2 minus. This is called a diprotic because it releases two protons. Phosphoric acid, H3PO4, is an example of a triprotic acid because it releases three protons and the 3 minus charged phosphate ion. Another substance that could be considered an acid is an acidic anhydride. An is a word part that means not, and hydra is a word part that means water. So these are not water acids. Here's what that means. They're acids that just don't have water yet. You can think of them as instant acids that you just add water to. Non-metal oxides will react with water and form acids. This is one that happens actually in your bloodstream. Carbon dioxide reacts with water and it produces the acid carbonic acid, which is H2CO3. Then that acid can further dissociate and give you protons and an anion. So acidic anhydrides are also acids. Bases are substances that are electrolytes, and these are things that undergo ionization in water to produce hydroxide ions, which are OH minuses, and a cation. So here are the types of bases that are available. One is just simple ionic compounds that contain hydroxide ions, like sodium hydroxide, NaOH, is lye, common household substance for cleaning drains and things. This is just an ionic compound, and it dissociates to give you Na pluses and OH minus ions. Basic anhydrides, like acid anhydrides, are just lacking water. These are metal oxides. So acidic anhydrides are non-metal oxides. Metal oxides are basic anhydrides. They'll react with water and form metal hydroxides. Here's an example. If I have potassium oxide, K2O, and I react it with water, here's what will happen. I'll end up with KOH. It's balanced that way. Well, that's a base, and then it will go on to split up and give you K pluses and OH minuses. A third type of base is something called a molecular base. There are some molecules that react with water to yield hydroxide ions as a product. Ammonia is sort of the classic molecular base. Ammonia reacts with water, and it's going to tear a proton away from the water and turn it into NH4+, which is the ammonium ion. When you take the H away from HOH, you just end up with OH minus. There's the hydroxide ion. So this is a base. Electrolytes have different strengths. We think about strong electrolytes as things that dissociate completely in water. In other words, there won't be any molecules, there won't be any crystals left. Everything that's there turns into electrolytes. What sort of things are strong electrolytes? Well, all ionic compounds are strong electrolytes. Some are more soluble than others, but they all split up into ions. Ionic compounds don't exist as molecules. Strong acids have complete ionization in water, and they are strong electrolytes. This is a short list. There are only 6 of them, and you should learn what they are. Here are the 6 strong acids, and I'm going to review acid naming for you here with this little device, ice skate and mouse bite, our little memory tools. Acids that end in ic come from anions that end in ate. Acids that end in us come from anions that end in ite. Well, all of our strong acids are ic acids. Perchloric acid comes from the perchlorate ion. Perchlorate is ClO4 1 minus, and perchloric acid is HClO4. Hydrochloric acid starts with hydro. If it starts with hydro, then that means it's binary acid containing only 2 elements. In this case, hydrogen and chlorine. Hydrobromic, hydrogen and bromine. Hydriodic, hydrogen and iodine. So 3 of our 6 strong acids just come from the lower part of the halogen column. Nitric acid is also a strong acid. Ic, 8, so nitrate is the anion. HNO3 is the acid. Sulfuric acid comes from sulfate, and so H2SO4. So these are our 6 strong acids, and you need to know what they are. So go ahead and memorize these. Strong bases have complete ionization in water, and so they're strong electrolytes. Now, what are the things that actually dissolve in water? Well, all group 1s, so sodium, lithium, potassium, that whole group, and some group 2s. And specifically, it's strontium, calcium, and barium hydroxides. So these are all hydroxide salts, like, for example, BaOH2 dissolves well in water, and that makes it a strong electrolyte. What are weak electrolytes? Well, weak electrolytes are just things that don't experience complete ionization in water. The reason that they don't fully dissociate is because before they completely dissociate, they reach an equilibrium, and the backwards reaction, the undissolving reaction, starts to happen at the same rate as the ionizing reaction. So weak acids, which are all the acids that aren't that group of 6, will reach this dynamic equilibrium and not fully ionize. So hydrofluoric is an example of a weak acid. It produces H pluses and F minuses, but it stops and it goes backwards before it completely dissociates. So you still have a bunch of molecules left, not so many of these. And then there are molecular bases that are all weak. So here's an example of that. CH3NH2 is an example of a molecular base. Like all molecular bases, it reacts with water, and it produces some CH3NH3 plus and hydroxide ions, which is what makes it a base. But it doesn't do it completely. You get that reversible thing. It reaches dynamic equilibrium before they all can ionize. So that makes it a weak electrolyte.